Our inspiration, Dr. Bhausai Panjabrao Deshmukh. I am going to deliver my talk on potentiometric technique under the head of chemical handling and laboratory safety. I am Dr. Shruti Pramodra Ingole, Assistant Professor, Department of Chemistry, Shri Shivaji Science College, Amravati. First of all, we are going to focus on potentiometric analysis. It is based on potential measurement of electrochemical cell without any appreciable current. The use of electrode to measure voltage from a chemical reaction. This technique used to measure the flow of electric current passing through the circuit. Basically, there are four types of different electrodes are used. First is a metal-metal ion electrode. Second one is a non-metal ion electrode. Third one is a metal sparingly soluble salt electrodes. And fourth one is a redox electrodes. Now, a component of a potentiometric cell. First is a reference electrode. Second one is a salt bridge. Third one is a analyte. And last is a fourth one is indicator electrodes. There are reference electrodes in potentiometric cell used for a standard potential. The reference electrode are of two types. First one is a standard hydrogen electrode and second one is a calomel electrode. We will discuss it later on. Now, a second one is a salt bridge. It is used for the migration of ions from one solution to another solution. It is used for the completion of circuit and regulates the potential of the cell. The analyte, it is a homolytic solution of electrolytes. And last one is a indicator electrode. These are the electrodes which used to indicate a completion of ionization reaction. Now, a reference electrode. It is a platinum electrode whose potential highest and considered as a zero potential. Half cell with known potential, that is a E reference. The E reference is a known electrodes. The reference electrodes, like a calomel electrode, are always kept at a left-hand side. Left-hand electrodes by conventions. Reference electrode, like calomel electrodes, are easily assembled. It is unaffected by small variation in methods and parameters, that is a RUJ. Now, RUJ, it is unaffected by a small variation in methods parameters. Insensitive to analyte concentration. It is reversible and obeys a Nernst's equation. It has a constant potential. It returns to original potential. Now, indicator electrodes, it generates a potential that depends on analyte concentration. It is a selective nature. It has a rapid and reproducible response. Now, a salt breach. It prevents mixing up of analyte components and generates a potential EJ is equal to negligible. The EJ is a unknown electrodes. The EJ means unknown electrodes. Now, potentiometric methods. Here it is a schematic diagram of the potentiometric method. The right hand side is a indicating electrode and left hand side is a reference electrode. The reference electrode, the part of the cell that is held constant, and right hand side electrode is a indicating electrode. The part of the cell that contain the solution we are interested in measuring. Now, a reference electrode, first is a standard hydrogen electrode. Second one is a calomel reference electrode. Third one is a silver chloride reference electrode. Now, a standard hydrogen electrode. The schematic diagram of standard hydrogen electrode. These electrodes made up of the glass envelope, platinum wire, and platinum foil covered with platinum black. These electrodes are fused with the H2 gas. This is a standard hydrogen electrode. Now, a saturated calomel electrode. Hg2Cl2 plus 2 electron. This reaction to fuse a 2Hg plus 2Cl negative ion. These reactions occur a reduction reaction. The always reduction reaction occur are reference electrodes. Now, these are the properties of a saturated calomel electrode. The saturated calomel electrode, the schematic diagram of this electrode. Now, a wirely here, then platinum wire, hole to allow drainage through a porous plug, Hg, Hg2Cl2 plus KCl. Then after the glass wool opening saturated KCl, then the solution, then KCl solid and glass walls. These are the outer layer is the glass wall, and this is a part of this porous plug, that is the salt breach, bottom of this electrodes. AgCl reference electrode, the schematic diagram of this electrode, then this reaction is AgCl plus electron to gives by the Ag plus Cl negative ions. These electrodes are reduction reactions occur. These electrodes are these reference electrodes, and reference electrode is always occur the reduction reaction. Now, a liquid junction potential. A liquid junction potential is an interface between two solutions containing a different electrolyte or a different concentration of the same electrolyte. A junction potential occurs at every liquid junction. The cause is by unequal mobility of the positive and negative ions. Now, indicator electrode. First is a metallic indicator electrode. That is a three parts of electrode. First is the electrodes of the first kind. Second is the electrodes of the second kind. Third one is the inert metallic electrode for a redox system. Now, second one is the membrane indicator electrodes. Then the fourth parts of this electrode. First is the glass pH indicator electrodes. Second one is the glass indicator electrodes for other cation. Third one is a liquid membrane indicator electrode. And fourth one is a crystalline membrane indicator electrode. Now, a last part for this gas sensing probes. Now, first of all, metallic indicator electrodes. Now, the electrodes of the first kind, it's a pure metal electrodes, is direct equilibrium with its cation. The metal is in contact with a solution containing its a cation. Here it is a Nernst equation at a room temperature. Here this equation are as a Nernst equation and room temperature at room temperature. So disadvantages of first kind electrodes. First is not very selective. Ag positive interferes with Cu dipositive. Maybe pH depends. Zinc and cadmium dissolve in acidic solution. Easily oxidize. Deaerations required. Non-reproducible response. Now, electrodes of the second kinds response to anion by forming precipitates or stable complex. For example, Ag electrodes means silver electrodes for Cl negative ions determination. And second one is a Hg electrodes for EDTA determination. Now, inert metallic redox electrode. These are inert metallic electrode means a redox electrodes. The inert conductors that responds to a redox system. It's an electron source or sink. An inert metal in contact with a solution containing the soluble oxidize and reduce a forms of the redox half reaction may not be a reversible. Now example is a platinum, gold, palladium and carbon. Now a membrane electrodes aka p-ion electrodes. It's a consist of a thin membrane separating a two solution of different ion concentration. Most common is a pH glass electrode. Now, glass pH electrode, the schematic diagram of the glass pH electrode. To a pH meter, now saturated calomel electrode. These are the situated in this left hand side. Solution of unknown pH, silver wire, thin glass membrane, magnetic stirrer, zero point 0.1 molar HCl saturated with AgCl, silver chloride. Heavy wall glass. Now, these are the silver wire, thin glass membrane, outermost part is the thin glass membrane, and then wax insulations. Wax insulation is part of this wax insulation, and this electrode is a glass electrode. Is situated in this right hand side. This diagram of this glass pH electrode. Now, a property of a glass pH electrode. The potential not affected by the presence of oxidizing or reducing agent operates over a wide pH range. Fast response. The property of glass pH electrode is a fast response, operates over a wide pH range. Then a potential not affected by the presence of oxidizing or reducing agent. Next is a functional, well in physiological system. This is also property of this glass pH electrode. The function well in physiological system. Then a very selective and long lifespan. These are the property of glass electrode. Okay. Now a liquid membrane electrodes. The potential developed across the interface between the analyte solution and a liquid ion exchanger that bond with analyte similar to a pH electrode, except that the membrane is an organic polymer saturated with a liquid ion exchanger. The use for a polyvalent ion as well as some anion. For example, a calcium dialkyl phosphate insoluble in water but binds calcium dipositive strongly. Now, a liquid membrane electrode. These are the schematic diagram of liquid membrane electrode. Calcium dipositive electrodes means ions exchange reservoir, sensing area responsive to a calcium dipositive, porous membrane, internal reference solution 0.1 molar calcium dichloride Ag oblique AgCl reference electrode. These are the schematic diagram of the liquid membrane electrodes. Now, a liquid membrane electrode, the reservoir forces exchanger into the membrane. The exchanger forms complexes with the species of interest. The result in a concentration difference and a resulting a partial volume means del V. Okay. Now these are the partial volume is a del V that we can measure. Now a characteristic of calcium dipositive liquid standard electrode, relatively high sensitivity, low load, working pH range 5.5 to 11, relevant in study physiological process. Now, a K positive selective electrode. Sensitive membrane consists of valinomycin and antibiotics. These are the molecular structure of valinomycin. These are the K positive selective electrode. Now, a crystalline membrane electrodes. The crystalline membrane electrodes are a solid state electrodes, usually ionic compound. It's a crushed powder, melted and formed. Sometimes doped to increases a crystalline membrane electrode is a sometimes doped to increasing a conductivity. Then a operation similar to glass membrane. These are the part of the crystalline membrane electrodes. Now, F negative selective electrode. A lanthanum trifluoride is doped with europium difluoride. Europium has a less charge than the lanthanum tripositive. So, an anion vacancies occur for every europium dipositive. A neighboring F negative can jump into the vacancy, thereby moving the vacancy to another site. Repetition of this process moves F negative through the lattice. These are the lanthanum trifluoride membrane. Now a fluoride electrode. The schematic diagram of the fluoride electrode. Next is a gas sensing probes. Now, a gas sensing probes, a galvanic cell whose potential is related to the concentration of a gas in solution, consists of a reference electrode, liquid standard electrode, and electrolyte solution. A thin gas permeable membrane serves as a barrier between internal and analyte solutions. Allow a small gas molecule to pass and dissolve into internal solution. O2 NH3 oblique NH4 positive and CO2 oblique HCO3 negative oblique CO3 di negative. Now, schematic diagram of the gas sensing probe. The diagram of this gas sensing probes. Now, direct potentiometry, a rapid and convenient method of determining the activity of cation and anion. Means direct potentiometry is a rapid and conventional method of determining the activity of cation and anion. Now, this potentiometric measurement is an ionic composition of a standard must be the same as that of analyte to avoid a differentiates. Swamp sample and standard with inert electrolyte to keep ionic strength constant. TISAB means T means total, I means ionic, S means strength, A means adjustment and B means buffer. Means total ionic strength adjustment buffer is a control ionic strength and pH of a sample and standard in liquid standard electrode measurements. Now, here are given a potentiometric measurement. These are the two types. First is a calibration method and second one is a standard addition method. The both graph, first is this graph is a calibration graph and second one is the graph is a standard addition. Now, special applications, a potentiometric pH measurement using a glass electrodes. First is a 1 drop of solution. Second is a tooth cavity. Third is a sweat on skin. Fourth is a pH inside a living cell. Fifth is a following liquid stream. And last one is a acidic of stomach. That is the application of potentiometric pH measurement for using a glass electrodes. Now, a potentiometric titration involves a measurement of the potential of a suitable indicator electrodes as a functional of titrant volume. Provides a more reliable data than the usual titration method. It's a useful with a color or turbid solution. It may be automated and also a more time consuming. That is a potentiometric titration. Now, the potentiometric titration curve. Here, the both are the potentiometric titration curve. Here, some applications of potentiometric analysis. Now, here it is a some snap of potentiometric analysis. These are the applications and useful for the potentiometer analysis. Thank you.